going to turn it over to Phoenix.
Hi, this is Phoenix.
Go Phoenix!
I'm Miss Jones, assistant principal.
Okay, and we're the STEM ambassadors. We're unfortunately missing 2 of our members, but I'm Andrea. This is Andrea. And we're from Phoenix, obviously.
Yeah. Okay, so these are our course offerings for engineering and computer science. So for rising 9th graders to 11th grade, we have Introduction to Engineering. For sophomores and to seniors, we have Principles of Engineering. For juniors and seniors, we have Civil Engineering. Aerospace, which I'm currently taking, is for sophomores to seniors. Cybersecurity is 11th to 12th graders. Digital electronics is juniors and seniors, and VEX V5 Robotics. Yep. Okay, it's rising freshmen to sophomores, and then computer science essential or mobile applications is sophomores to seniors.
Okay, so I would just like to add for our introduction to engineering and our principles of engineering, those 2 courses are actually offered throughout the summer. So like 8th graders coming into freshman year, they can take a 5-week course program throughout their summer, and then that's how those are the 2 classes that they take, and it gives them credits for when they come in as freshmen, and it also helps them like get more advanced classes based on like their performance in that class. And then our 2023 to 2024, those are actually upcoming classes that we plan on like having next year. And then our VEX V5 Robotics summer is actually a summer class that we're working on for this summer, which STEM ambassadors are actually going to be helping out with that.
Yes. And another course that we have is AP Computer Science Principles, which is available for incoming or for rising freshmen and rising sophomores. I took it and then I was enrolled into AP Computer Science Principles, which is a great course.
Any questions? Okay.
So is that computer science essentials? Is that teaching how to write apps?
So during the summer, we worked with things like with that. We worked with that, but during the actual class, we focused more on like doing block coding, and we did a little bit with like JavaScript, but we were mainly focusing on block coding and like algorithms and working with stuff like that.
Next slide. All right.
Next slide.
Yes, please.
So this is me. Okay, so I am the captain of the Phoenix STEM Military Academy robotics team. And here you will see are just like a few of our members explaining like what we're doing. You'll actually see me kind of in the side of the bottom photo, but at the top, you'll see like I was doing almost like a mock competition because we have not competed yet, but we actually plan to next year. We have a very new team who's only been around for like a year-ish. So we're very, very new. We're starting from the bottom up. And this year we've actually made progress, which is those 2 robots that you see in the photo to the right. Those are actually like our newer things. We've made those this year. And then again, photo to the left, you have like a mock competition almost. All right. Next slide.
Okay, so these are actually our projects that we have been working on in aerospace engineering. So all the way on the left, we have our satellite. We actually don't have that with us right now, but it's supposed to be like a mock of like an actual satellite in space. And it's like, it has a distance sensor. It's at the very bottom right. And it goes through our wooden beam, as in like if it was in space. And the sensor detects if there's something like on the ground. So then that's what gives us our data. And then it gives us like a surface map of what our surface looks like. So we move our beam like every 3 inches to get like all of our surface. and then it gives you like a mock like surface based on like the data, the distance sensor collected. And then in the middle, you see our elevator, which was actually a final project. And we had a test bed in which we learned how to use everything, like our motors, our gears, everything. And our final project was to make an elevator. The only instructions our teacher gave us was we can have one motor. We have to obviously code it. It has to work. And we have to build our elevator from scratch. So everybody's elevator is different, but this is what our elevator ended up looking like. And we actually have it right here. I don't know if you guys can see it. And then on the very right is our rover, which is actually right here. And it actually does different things. Our first assignment was to just make it go forward, just make it go. We obviously have to build it as like a team. And then our most current assignment, it uses a distance sensor and an optical sensor. And the optical sensor, we programmed it to detect a certain color, so like a hue. And once it detects that color, it'll go until it detects that color. So if like, for example, we chose blue, it would keep going until it detected the color blue. Once it detects the color, it'll stop, pick up an object, go back, turn a different direction, and then leave the object somewhere else. So those are our 3 main aerospace engineering projects.
Next, okay. So at Phoenix, we're able to get opportunities to go to different programs. So me, Andrea, and a few other of our classmates went to the U.S. Naval Academy during the summer, last summer, before this year. These are the classes that I took. We were all in different sessions and different platoons, so it just depended on like what platoon you were in. But the class that I took was ocean engineering, algebra 2, computer science, aerospace engineering, robotics, circuits, meteorology, and paleotempestology. That's a really good word. Yeah, it's a really good word. So the last word is it's based on like weather. It's like wind speed. So we had to build a house, and there was like this machine that was pumping out a lot of wind, and you had to make this house like sturdy enough. And I think it was actually like a pretty good like experience, like overall. Obviously, like there was like the most social part was like, oh, I meet people from all around the country, all that good stuff. But then like educationally, I got to like learn like different things, and it like opens your like eyes to see like maybe like things that I might want to pursue in the future. And yeah, so it gives me a lot of like different options on like different things. And yeah, it was like actually really fun and really educational. A very good experience.
Yeah, and I just want to say to wrap us up, I think it was there, you can jump in, but I think it was like the early exposure to STEM and robotics that actually prepared them for this journey to for post-secondary. So going to go see the U.S. Naval Academy, work with robotics in their labs, go to University of Chicago, just like tinkering with robots just opened so many doors for our students. So, thank you.
That's all. Thank you.
Thank you.
Do folks have any questions for Phoenix? If there aren't any right now, we can move on. But that was
I do. Regarding some of the aerospace robots, the satellite. I thought that's a fantastic idea. The sensor, which is looking downward, what type of sensor is that? Is that using infrared?
That for the satellite, it was a distance sensor, and basically it would measure the distance between the actual satellite and the floor. So if there was like, obviously when we made our terrain, there were things kind of in the way, so that like it would be different in our data based on like where the objects are placed.
It was a laser sensor, so when it's on, there's a light that turns on, but So it like tells you that it's on, but it uses a laser to like sense the objects.
Yeah, measure.
Fantastic. Yeah, they call that LiDAR. That's actual technology. I didn't know that they had those type of sensors for VEX. That's fantastic. The other, I guess is more of a comment than a question, is regarding the elevator. You mentioned that you did the programming for that.
Yes.
You know, every elevator, a real elevator, when you're inside, it has a button to you know, hold the door open. And then they usually have another button to close the door. I've been told that that button is never connected to anything, and it's just there for impatient people to push to have something to do. I don't know if that's true or not. Maybe that's something you could evaluate with a program.
Yeah, we weren't really thinking of that while we were doing our programming. Actually on the side of our elevator, we have the different like buttons for each floor. So there's like the third floor, the second floor, and the third floor. And there's actually, oh, first floor, my bad. And there's actually LED lights connected to each button. So it's supposed to work like a real elevator. So like when you press like the third floor button, the LED light will turn on. Once you get to the floor, it'll turn off. And it'll work like that for every button that you press. So it'll go like back up and back down. Huh?
That's very cool. Thank you for sharing those projects.
Thank you. Thank you. Do we have any other questions?
So wonderful. I hope you all will stick with us and hear from the other schools, and then we can all have a conversation at the end. So I think we are headed to Curie.
Okay, so my name's Dr. Catty, and I'm Notorian Johnson. So Notorian was the lead student. He asked me to start a robotics club, which we started last year. It was our rookie year. So there are two main competitive robot clubs. One is FIRST and one is VEX. So the only reason we went into FIRST is we had a bigger support system in FIRST than we did with VEX. So that's how we ended up. So we started with a wrestling coach's interpretation of a robot as our logo. and at least this year we've made incremental improvements. Yeah, they call it, right. Next slide. So what I really believe in is the first kind of principle is that we're here not just to build robots, but we're here to build people. And this is, robotics is a new way of getting a different kind of leadership in the system, rather than just having athletics as a path to leadership. Robotics, I think, can be a huge path to leadership, whether you're doing the fundraising, or whether you're making the portfolio, or whether you're on the team actually doing the engineering. There really is room for everybody. And having summer internship programs either around robots or around building really helped our team as far as we've come. This is our second year. We actually made it to the Chicago area semifinals, which is considered a pretty big deal for a second year team. Next slide.
Okay, so the competition is basically, it's called First Tech Challenge, where we make our robots. So on the left side on the slide, that's Bumblebee 1, which is this robot right here. I wonder if you can see it good. And then the one on the right is BB2, so basically Bumblebee version 2. So we made 2 robots for the season. So in FTC, everyone's really invited. Like, you're a programmer or artist or someone who's good at designing or drawing, because we had to make notebooks. We had to draw everything out for the robot. And also computer-aided design and everything, because I had to design these 2 side plates. They're made out of polycarbonate. or whatever, which is really fun for me because I get to be creative when it comes to this stuff, like with the numbers on our robot, like they're yellow and black. So just like the wheels on the robot. So we call it Bumblebee, the motors.
So here's an example of just how we start in FTC. So you have two teams playing against two teams, and then like every team can have three, well, it can have four people actually. We have a coach, one player, a second player, and then this person's job is to put the these cones inside according to certain rules. And then we had the pleasure last year, and so did Phoenix, Hyde Park, at another school, to do Shifting Chicago Narratives and to tell our story of how we went from the pandemic and how robots helped us become productive. And you know, one thing that I really believe in robotics is it's, you know, it'll break 1,000 glass ceilings. It'll it's the rope that pulls people out of poverty. I mean, I truly believe that it's the way to get out of your hole and into something either technical or into a leadership type role. Next slide.
So during the season or during the competition, we would sometimes have we obviously we had to build a robot. Like we had to put these metal plates together, and as you can see, mount motors and wheels and everything. But as well, we would have to do troubleshooting because we have multiple competitions. And the thing with robots is that they vibrate a lot, so screws come out all the time. So we would find ourselves always having to screw in different screws. Like in one of our matches, a wheel came off, and then we had to take it right back to our pit and just screw in every screw just one to make sure that never happens. And it basically shows you like basic mechanical things like how to make a lift, how to put wheels on there. And also I use a lot of YouTube, so it makes you get a lot of information because looking up how to build robots, you can find it online easily, but it's not something you just find out in every school on how to build a robot. And like the question would be is like, how do you screw in a screw? Some students don't know how to screw in a screw. Oh, then you gotta like screw it clockwise. So yeah, you have to use like a lot of information online, and it basically gives you skills, a lot of hardware skills.
You start, you know, you order something, you get a bag, okay? And they don't even give you, only for the chassis they give instructions, at least in Go Builder. So for example, this elevator, this lift here that we have, it actually took us 2 years to build, and it started just as a wrapped piece of paper. And we had to go from the line they gave us to 5-pound fishing line to 30-pound fishing lines, finally to Kevlar. And like we 3D printed the claw. It's actually very similar to the Vex, the original Vex Clawbot design. And we actually use a Vex motor, which we're allowed to use, but not Vex structures. So, you know, the second year we had almost all seniors. So we were able to have knowledge that we didn't have beforehand. Next slide.
Okay, so next would be like.
Sorry, we actually have a question about your last slide.
Go ahead.
So you mentioned that, I think you said your wheel fell out during competition or something like that. Does that actually like, do they take points away for that? Or like, how does that work?
No, they don't take away points. You just can't score or do anything once your wheel falls off, like during the match. You just can't do anything. Your robot's immobilized. So you're just trying to figure out what to do. You're like surprised. But it was a good thing that it was near the end. Yeah.
So what I learned, my fiance happened to be on the judges panel, and what I learned through her was if our wheel hadn't come off, we actually would have gotten one of the awards, but because our wheel came off, that dinged us on something, and we weren't able to get an award because of that. So so there are two things going on. You get scored in the competition by points, but then I'll talk later about the other part.
Okay, thank you.
So you have 3 competitions. Oh, go ahead, Victoria.
All right, so basically in a competition, we would have to strategize because there would be like as Knox said, there were different positions. Like there would be a coach, there would be 2 drivers, and there would be someone placed in cones. And it was our job to be, because it challenged us to be social, because since we never know who's going to be on our team, because the matches are 2 versus 2 matches, and they could be with anybody who you went up against, you have to always strategize with the other team and find out. Like you have to go out there and ask, what can your robot do? And how can it score? And we have to see the best way to score. Like some teams will just, as you can see those long sticks. Oh, I should show it on the computer, but you basically, would you just pile them up on one thing and just score? Or would you or you could get a circuit. If you ever played tic-tac-toe, basically, you go from one side to the other and you get a lot of points from that. So you basically have to strategize. And also we're gonna talk about programming too. So basically, because I was basically the main programmer, and originally programming was very hard because I didn't know, like the teacher in my first internship showed me how to program, but they were with completely different wheels from these, because these wheels can go horizontal, they could go like vertical, and they could like go diagonal to the left and like to the right. And for that requires different math, which challenged me to figure out how that worked. But I mostly got most of my information from YouTube, as well as these robots. This season, we use these are like little tags. Like you could think of them as QR codes. And basically the camera would scan these QR codes, and they would go to, the mechanical, and they would go to the different zones where you would have to park, and they would give you a lot of more points for it. And like one of the challenges was, before you even go into the match, you have to make sure our camera was always facing it, because if it couldn't see it, it wouldn't be able to give us those extra points that we needed. That's it.
So the second part, so we have 3 competitions, and then what's called a qualifier competition for state. So when the qualifier competition, you have to give a presentation to the judges. So this is basically most of our team. I think there's 1 person missing, but we really only had 4 people coming regularly, and then others would just kind of come in and out. And we actually had to put together an extremely thorough portfolio, which actually I only learned at this presentation. They kept using the word engineering notebook, but that's not what they meant. They meant portfolio. And they're really amazing. If anyone ever wants to see one, I can share it. You can email me or email Ms. Reynolds. So, and then based on this interview and then subsequent interviews that go on during the day, you can get one of like 7 awards. And they're very, very strict. And they don't believe that everyone should get an award. So some teams got 3, 4 awards, some teams got 0. But you know, like there's awards for outreach, you know, like, you know, who inspired other people into robotics through outreach. I mean, there are like 7 different types of awards. We didn't do much fundraising just because we barely had enough to have a team to just build a robot. But that's definitely something that needs to be done. And that adds points in this. But we did make it to semifinals, and that was really amazing for us for a second-year team. Next slide. So one thing that was interesting that happened is one of the really good teams had bent their axle, and we had, it's instead of hub, it should be axle. And I actually had 4 axles. A big email was sent out, and I brought my axle. And if we hadn't brought those axles and given it to them, even though they only needed 1, they wouldn't have even been able to compete. But they actually competed and went to state. And you know, it's all about this concept of gracious professionalism, because you're 2 teams playing against another 2 teams, but then your teammate could be your opponent in the next round. There are 5 rounds per competition. So they have this concept called gracious professionalism. And so we gave the bent hub, we gave them replacement hubs, and they went to state. And it's like, well, I feel like maybe part of me went to state too. We needed some wires, and we got some extra wires so that we could lengthen. We needed more distance because of the climb that we were doing. So this concept of gracious professionalism really hit home. And this is our last competition. So, and we have the Notorion's mom is in there, and Julian's dad is in here. And then Mr. Nieto, he was able to co-coach with me for 2 months. I did coach this for 2 years on my own. It was a pretty heavy lift. Next slide.
Oh, we have a question real quick.
Yeah.
When does your season start for like competition?
They announced September 15-ish, and then like October 10 is like the first competition, and then the qualifiers are in February.
Oh,
and the state just finished.
Okay. So I have a question. Like, when do you guys start practicing? Like, do you guys recruit people during the summer and have people practice over the summer?
No. So what we've done is we have hooked up with Lindblom Science Academy, which is very close to where most everyone who goes to Curie lives, and they have an internship program. So I send our robotics people who want to work this summer and get paid this summer to the Lindblom robotics program or internship program, and they usually have some robotics projects and building projects depending on their level.
Okay, thank you.
Thank you.
Sorry, I'm trying to get off mute, and now I finally am. That was so wonderful. That was so inspiring, and you all are doing an amazing job with not a lot of resources in such a short time. Torian, I'm so glad you could join us too. And I think if IMSA's ready to turn it over to them, and hopefully Curie, you can continue to hang out and we can just keep having a conversation.
Yeah, I don't know if I'm starting our section, but I guess I can start off. Start off our section. I'm Cole. I'm the programming head from IMSA Titan Robotics. On the slide here, you can see a couple ways to get in contact with us. That's our website, our Facebook page, and Instagram page. And so, yeah, we are the robotics team from the Illinois Mathematics and Science Academy, IMSA. IMSA has on the next, or actually if people are still using the slide, we can say here, but on the next slide, you'll see that we have 2 different levels of robotics. We have FTC, like you just heard a lot about, and then FRC. The FRC team is the team that I'm on, so I'm going to focus mostly on that, and also because you just heard all about FTC, and the Curie team is a wonderful resource if you want to reach out to them for more about that. And of course, IMSA Robotics is also happy to help if you have any questions about that. But I'm going to talk a bit about the FRC side of robotics. We are much larger teams and much larger robots. You can see an image of one of our past year's robots in that picture there. I believe that was, that appears to be the robot from 3 years ago, I believe. We have a team size that's typically closer to 50 people rather than 15 people. And so we have a much larger team with a lot more opportunities for both specialization and getting into lots of different areas of robotics. I apologize if you can hear the background. I am IMSA is a residential academy, so I'm living on campus, and so you can hear our announcements in the background. I apologize if you can. So to fund such a large robotics team with such a large robot takes quite a bit of funding. I believe our funds raised per year is on the order of about $40,000 per year. So we have quite a few sponsors that help us out both with dollars and with in-kind donations. So the in-kind donations are things like donating parts or donating machining capabilities or donating things of that kind. Because it is very resource intensive and very expensive to build these robots and to pay competition fees and to run such a large program. So you can see a couple of our sponsors here and a more up close picture of our robot from last year. On the next slide, I can talk a little bit about how our team is structured. This is one of the interesting distinctions between FRC and FTC is that FRC is so much bigger. And so we have a much more complicated structure. We actually just this past year reorganized our team structure because we had a slightly more flat structure that only had 2 levels to it, and we found that that wasn't working well enough for us. There was not enough communication between certain parts of the team that needed to have communication, and there also wasn't enough resources dedicated to the operations side of our team. And so we reorganized to give more direct attention to that part of our team. So the way that we are structured now, we have a senior captain. By the way, we are entirely student run as far as the leadership of our team. We do have mentors who are incredibly valuable resources to our team, but the leadership of our team is all student run. Our senior captain is the head person on the team, and the junior captain is a junior who is essentially shadowing the senior captain to be able to take the role the following year. And so every year we select a new junior captain from the rising sophomore class who are going to become a junior. Our school, by the way, only has 3 grade levels, so we also have a faster turnover rate. And so this kind of helps account for that. Then the next level of leadership is we have a technical team and an operations team. Within the technical team, we have a team head for each of the sub-teams that you can see up there, and same thing within operations. The size of these teams vary, but the smallest are teams like finance and electrical that only have around 4 or 5 members. The largest is probably mechanical, where I think they have closer to 12 or 18 members on that sub-team. And these members are from all grade levels and a whole variety of different experience levels. But because we have such a large team, we're able to allow students a large variety of actual leadership roles that get them in a real leadership position. And we also are able to provide teams with a large degree of specialization. So with our programming and electrical, I think we talked about this a bit on the next slide. We are able to get into a lot of, it appears that there is no text on the slide, but we are able to get into a lot of technical detail and technical, very advanced technical concepts with all of our sub-teams. I'm the programming head, so I can talk a bit specifically about that. I'm hoping that our design and mechanical heads will be on a little bit later, but our school day actually just ended, so they are probably still getting out of class. On programming, we run everything from regular motor controls and mapping inputs to motors all the way up through much more complicated things like working with Riemannian motion policies, which is a motion control algorithm based off of differential geometry that was published in a research paper 2 years ago. We work with vision and 3D mapping of the field and localization of the robot in 3D space. We work with sensor fusion to combine odometry and vision and visual fiduciaries, which are basically QR code type things scattered around the field. On our design team, we make heavy use of CAD, which I would imagine FTC also talked about. I apologize, I got here partway into their presentation. We make heavy use of CAD for designing all aspects of a robot. We have a long and rigorous design process for our robot. We do similar like technical advancement for electrical and our other subteams as well. So just to give everyone an idea of this is what FRC offers. Please stick around and ask questions if you have questions about the specifics of this. And then on the other side of this, we have operations as well. Yeah, on the other side, on the next slide, we have a lot of expertise in advancement with operations as well. The heading of the slide, Titans Teaching Titans, is one of our kind of core ideas, both at IMSA in general and on the robotics team especially. All of these topics I've been talking about, these are things that the leadership of the team, so the students who have been on the team before, are teaching to the new members on the team. So these are all things, the mentors aren't coming in and telling us here's what to do and how to do it. This is entirely student-led, so it is students learning how to do this and then teaching each other how to do this and working together to decide what is the best solution for our robot and our team, considering our resources and our constraints. This plays out both on the technical side. Yeah.
Let me jump in real quick because I think Phoenix has a question too.
Ooh, yes. I'm sorry, I'm not seeing the question.
Can you talk a little bit about the lab space? That's what she was asking about.
Yes, our lab space, I think we have a picture of it on the previous slide. We are very lucky to have IMSA has a space for our lab that we use. I don't know the exact size of the lab. It's a decent size. We share it with FTC. It's not especially large. It can get a little bit cramped if you have lots of stuff laying up, but we try to keep it tidy so that we don't experience that. But it's large enough where we have a CNC machine. I forget the exact model of it, but I'm sure that when our design head gets here, he'll be able to answer that if you're curious about that. We also are lucky enough at our school to have access to a makerspace at our school, where we have access to 3D printers and we have access to like engraving material and all sorts of other makerspace type materials. In our lab, we are also able to have we are also able to have like advanced, like high-powered saws. We have one that we call Sparky that we use for cutting both metal and wood. We have another bandsaw that we use pretty frequently for cutting pieces down to size, and a whole bunch of Dremels, drills, impact drivers, that sort of thing that we have access to. We have soldering equipment, and this is all stuff that we train our members on how to use. So if you're interested in providing that kind of resources for your team, this is a great way to get experience with working with that kind of tool.
This is also, I'm going to jump in really quick, Cole, where some of the donations, when we talked about the financing and money, are in-kind donations, versus just dollars, that we've partnered with different companies, organizations currently and in the past that will give us machinery, give us the consumables. It's just finding a place to put it, which I get in schools is really hard. But we looked at what used to be like your traditional shop class in school, and that was the area that was redesigned as really a maker's workshop, so a maker space at the macro level.
Great. I think Phoenix has one question too, right?
Hi, I'm sorry. We actually brought down our tech guru, Mrs. Tobias. Say hi. We have a question about the makerspace and like what's in your makerspace, or how did you design your makerspace? Because the floor plans, because we are actually in the process of designing 3 makerspaces.
Ms. Rowley, do you know a bit about the floor plans for that?
Sure. I was going to say, I know that we've exchanged emails, but I put my email in there. The other email I would include, I will type in Grant Bell, who is actually our robotics coach, is also our makerspace manager. He runs both robotics teams, the FRC and the FTC, as well as managing our makerspace, as well as now managing that makers workshop at the macro level. And then Pat Young, who is on this call, has joined kind of that group. He is really focused at emerging technologies. And so for Pat, there's some crossover between the makerspace, the macro makerspace, robotics, and the math badging, and trying to blend all of those pieces together. But if you want to email myself and Grant, I can send you the actual floor plans. We can also tell you the do's and don'ts of things that look really cool, but are really not as helpful. Even though they look great in a catalog, but they really don't look great and work great when you have students using them. Because that's a whole nother bigger conversation at the same time. So do that and then come out and visit, and we'll have a group that can certainly talk through what we did.
I'm sorry, Mr. Bias is very excited. We want to see the makerspace. We want to have a field trip. So yes, I will connect with you so we can arrange a field trip. On a Tuesday or Thursday? Tuesday or Thursday. Thank you.
Hey, I want to come when we want to come too. Maybe we can get Curie to come too. So go ahead if you want to keep going with the presentation, that'd be great.
All right. Yeah, so moving to the more business side of things, the more operations oriented side, we have 3 sub-teams: outreach, communications, and finance. Finance, as the name suggests, is in charge of managing all of our team's finances, so managing all the donations we receive, managing all of the funds that we have to spend in order to purchase our materials, managing our competition expenses, managing hotel rooms for our team when we go to competitions. They're often further away, managing costs for transportation and meals and all of that. I just want to point out in the chat that there seems to be a makerspace tour of sorts going on, as well as you want to see Ms. Rowley's Zoom.
Perfect.
And just like the rest of our team, this is entirely student run. The one thing we do go through our school, of course, to actually fulfill the order requests, but all of that originates and is tracked and is reviewed first by our own team members on our team. The finance team also handles reaching out to potential sponsors and soliciting donations, working with sponsors to work with them to make sure that we can have the best agreement for both us and them for what our needs are and what their resources are and their interests are. When I believe our one of our outreach people is going to be on the call later. I don't know exactly when, but I'm hoping they're here soon to answer more specific questions on that. But that's kind of an overview of what finance does. If you have questions, please ask. I can try to answer. But our outreach people will be able to give a more thorough answer to that.
Great. Next slide.
Yes, please. We also have, so operations subteam is kind of the overarching name for that, all of the operations aspects of the team. We also, outreach is another major component of that. That outreach works with collaborating with other clubs here on our campus to hold joint events to spotlight the role that robotics plays and STEM plays in all assets of the world, really, but also how people from all backgrounds participate in robotics. So we just recently held an event highlighting the role of Native Americans and Hispanic people of Hispanic origin in robotics and in STEM with another club on campus called SACNAS. And we plan events like this throughout the year by reaching out to these other organizations, both within our campus, and we also try to have some outreach to the larger community, reaching out to other teams, for instance, to like we go to an event each year that's hosted by a nearby team where we have an opportunity to exchange ideas with what they are building with their robots and what we are doing with ours and what other teams in the area are doing, and have a chance to kind of have a friendly, like official competition with them. We also reach out to teams at other levels of robotics to try to mentor them. We had 2 FLL teams, which is another level of first, if that wasn't discussed, that we have reached out to try to start mentoring this year. And we hope to continue expanding this type of thing in the future. And so, especially if you are a team that already has a first team of some sort, or if you're looking to start a new one, if you reach out to us, we are happy to provide any assistance that we can, and to reach out to you through our outreach to work with you more closely too. Yeah, come visit us. We do work on having teams come to visit us, and perhaps we could work out a way to visit your facilities as well. And then, yeah, I think that's the end of our slides.
Terrific. Yeah, so fun. I want to just open it up. I know you all were such good stuff, and you all are having lots of questions, so have at it.
I see a question in the chat. We are not in Chicago. The Illinois Math and Science Academy is actually located in Aurora, Illinois, but our students come from all over the state. We have students from as far south as Carbondale. We have students from the city of Chicago. We have students from the northern suburbs of Chicago and from north of Aurora as well. We have some students that live like 5 minutes away, and others that live several hours away, which makes logistics a little bit challenging for getting around for competitions. But it also means that we are a fully residential academy, which gives us other trade-offs where everyone lives on campus. So it's a really interesting dynamic living here and also going to school here.
Phoenix, did you all have a question? Did you all have a question? No.
One of the more significant donations from, gosh, probably 8 or 9 years ago is they had a group provide a trailer in order to hitch to vehicles to put the big robots and all the equipment and supplies in. And so we have that IMSA Titan Robotics trailer that goes behind the vehicle. And that was really significant versus trying to figure out for each competition how to get stuff where.
Yes, that has been a huge help to our team. Speaking of sponsors, one of our other largest sponsors is Caterpillar, who sponsors our competition expenses for 2 competitions every year. That amounts to a very large, I believe that's about $10,000 in total. So finding these sponsors that are able to sponsor specific things is a very useful way to find very valuable sponsors for your team if you're looking to expand your team or start a team.
I'd love to hear IMSA, since it seems like you guys have so much experience working with sponsors. What is the advice that you would give to how to do that outreach and what you need to provide to convince the sponsors that it would be something that they should invest in?
Someone from our finance team would be able to more thoroughly answer this question. So I encourage you to reach out to us if you want a more thorough answer. But I do know a bit about the process. I know that we reach out to potential sponsors through email. We try to rely on, if we do have a team member who has a connection to a sponsor, we try to reach out through that person. There were a number of years ago, we had someone whose parent was affiliated with Share Machine, and they became a very valuable sponsor to us for a long period of time. They were an in-kind sponsor providing us with sheet metal. I know we also have a sponsorship package, so we have different tiers of sponsorship that we offer. and that we also send out newsletters and updates, and we try to very hard to keep our sponsors abreast of what it is that we are doing to keep them like involved and engaged in our teams.
So I think that's significant. They've got a really robust social media outside of just IMSA. So sponsors see, so they know what they're paying for. It's also helpful, much like your sports boosters, that we have a 501c3 charity designation attached. So it's not coming directly to the school, but it goes through a 501c3, which allows a company to write that off. So your bands often do that, your sports often do that as far as having a booster that has a charity designation, and that becomes significant for some of your bigger donators, is that they can use that for tax purposes. So however your school sets that up, most of the donations that come through, other than those that are in kind, come through our IMSA fund versus IMSA as the school or as the state agency.
It also, as a practical matter, just for schools considering setting up teams, the ordering process, you can give some thought to that. IMSA has worked with us, and I want to thank IMSA for working with us on getting a very fast turnaround time for ordering processes. But I know that that is something that a couple other teams have struggled with, is oftentimes if you make donation directly to a school, that the funds then have to be released by the school, which can be a very long process that you don't necessarily have much time for during. FRC runs on a very short season. Our season starts in mid-January and ends, let's say we are about to enter week 1 of our 6-week competition season. So we have about 6 weeks to build the robot before the first round of competition season starts, and then another 6 weeks until the competition season is over. And so we have a very fast turnaround time.
That's been so helpful. You all are doing such amazing work, and I can't tell you how appreciative I am that you've been able to share this. And I'm really looking forward to being a part of the continued conversation and the visits, even more fun. As we're just signing off, I think my colleague Heather is going to throw in the chat a little bit for you. We do have some resources about how to construct really nice team-based challenges, which is a part of the pathways work that Ed Systems is doing. And also she's going to throw in there a link to our math badging initiative. So as we've talked about how much math is in all of this stuff, so there are some links, and I will stay on for as long as you guys want if you want to keep talking. But really want to let you go if you need to go, whatever your next 5 o'clock thing is. So appreciate your time and can't wait to keep the conversation going. Thanks so much. All you.
Thank you. Thank you. Bye.
We'll be in touch.
We will.
So we have a question about what's the next steps for FTC.
What do you mean by, can you elaborate on your question?
To start a team, what's the next?
So to start a team, so the question, are you in Chicago? If you're in Chicago, Jonathan Weiland is the contact. If you send me your email, I can connect you to. And he will walk. So rookie teams get $3,000 up front, and they get materials, and he can hook you into starting up. So here, I'm going to give you my email. Oh, okay, perfect, yeah.
You all are so generous. What a generous environment. It's really, I'm appreciative.
And he can hook you into some of the social event kickoff events at the beginning of the year where freebie stuff gets distributed.
And then I will also offer Cole and his team up. Once you have some kids that want to talk to kids, so just to be able to exchange their excitements, their challenges in ways that as adults we can try to translate to the kids, but students hearing it directly from other students who are living it, I think is invaluable. And so I know their team has lots of communication avenues to be able to share what's going on.
Yeah, maybe Angie, you can help me get some of those things and I can put them, I think I'll probably write something up about all of this and I can distribute that through our networks too.
That would be awesome. And then anybody that, people weren't able to meet but still want those resources. I know that one of the challenges, and Cole, you can interrupt me, one of the challenges, not challenges, but maybe challenges is just we want to help and finding people who want the help. And so we're excited to do that. It's just finding the people and where they're at and what they need. So that would be great.
Okay. I don't know if it was given out already, but I know there is an email specifically for the Titan Robotics team. I'm not sure if you have that already.
You want to throw it in the chat, Cole, if you know it? I know it's on some of the slides, but I don't know if I put the... Let
me just verify that. I always forget whether the extension is at gmail.com or .imsa.edu.
Okay.
So let me just verify which one that is, and then I will send that.
And there's a Facebook of Titan Robotics. I mean, that's where, as I took over into which meant I got Grant, which meant I got robotics. So about 4 degrees separated from this, started learning people. And our adults are good, but our kids are great. And so that's always the source I go to.
Our adults are good, but our kids are great. That's going to be my title of this write-up. Terrific.